So I'm going to go ahead. Okay, this is August 19th, 2015, and this is a workshop for middle school teachers from basically throughout the United States with an emphasis in helping and getting started with the Friendship Academy in Washington, D.C. So I want to welcome you and thank you for coming. And just want to kind of get started on this. I think you all got an agenda. We kind of put out an agenda of what we're going to look at and how we're going to get started. The purpose of this workshop is to equip the teachers and equip you with the understanding of the EPICS design model so that you can use it. Also, we want to develop a network of teachers so that as Adam gets going into his projects and he needs maybe some support or he's working on a project, we can connect him with other teachers that are also working on similar projects, or maybe connect him with another school in the Chicago area or in Washington, D.C., connect you with other schools. So we're going to try to develop a network of people that will help to develop that. And then also we want to give you an overview of the EPICS middle school curriculum so that you can use it and also to see what's there for your use. So that's kind of what we're going to be working on in the next couple hours. So we're looking at working till 5 o'clock or thereabouts. If we get done ahead of time, obviously I'm not going to say, oh yeah, we got to keep going. But that's what we're going to be working on over the next few hours. Wanted to talk to you about what EPICS is. EPICS was, and this is kind of a historical piece, some of you already know this and some of you don't. EPICS began at the college level at Purdue University in 1996 as a way for engineering students to have authentic design experiences before they got out into the field. And so they started looking at it of how could they best meet needs of students and then also get the biggest bang for the buck, so to speak, with reaching people and helping people. So they decided that it would be through service learning. And service learning is one of those things where it's not just where the students get all of the benefits of it, but also the community gets benefits. So it meets, and it's not merely volunteerism, it's where the students are meeting academic learning critical thinking and problem solving along with meeting needs in the community. So service learning is a lot different than volunteerism. It is real design. So the students really do work through a design process and they really do work through an authentic way of problem solving and trying to figure out how best to meet needs. It's a collaboration between all of those parts, the community, the stakeholders, the students, the academic pieces, and corporate sponsors also. And all of the curriculum aligns with the next generation science standards and the Common Core, which a lot of states, and we're kind of in an interesting place in the United States right now, with all states kind of taking Common Core and making them their own. So we kind of we're looking at all of the states and what those what their state standards look like compared to that national model to see how it works. What's nice about those standards is that it has not merely content, but it has process. So all of the standards are aligned, that all of the lessons are aligned that way. So that's what a bit of EPICS is. Human-centered design EPICS is based on human-centered design. And I'm going to break for 1 second, and we've got 2 more people coming in, and I'm going to ask them to put in their webcam. So I'm going to see if we can do that in a minute, and I'll keep moving along as I'm going. But human-centered design, EPICS, is a program, and the design model is not merely engineering, but it's also engineering with the focus on human-centered design. And human-centered design is not merely it's not merely a design model. It's a process, which is a model, but it's also a mindset. So we are always continually looking at how we can meet the needs of people, but we also have to have that constant iteration and the constant talking with the people that we're working with. So with this process, as we're working through this, and if you look up here, and I think you all can see that, I'm hoping you can, is our EPICS design model. And as they move through this project, the different phases of the engineering cycle, there's this constant iteration that happens between the users, the ideas that are needed, defining what needs to happen, and also is able to move to the next phase, or it goes back to an earlier cycle, so that it ends up being a process that works for the student and for the teacher and for the stakeholders. So this is the engineering design model that you have here, and the mindset is that it is about real design, real people, and real impact. So that's the whole piece of EPICS. Now, as an assignment, one of your assignments was to talk and go through the videos and so forth, and to learn a little bit more about that. And so I wanted to ask you a question of, why is this type of design essential for the EPICS? So I want you to think about that. And does anybody have an idea about all of that? So Julia, I kind of lost your video, and I see Tish is on, which is great. Tish, are you there? Okay, Julia's back up. Yay, Julia. Okay, you're not, we can't, okay, we're not hearing you. Can you hear us? Okay. Okay, now we can hear you, I think. Good. No, we're not hearing you. Okay, keep going in and out. If you want to call me, go ahead, and that way, as you talk, I can just put my phone up to the microphone, and that can work. Tish, I'm going to ask you, Tish is our teacher from Cincinnati, and I just sent her a web request so that she can get in on this conversation too. Adam, since you're up, I'm going to kind of put you on the spot, and can you tell me why this type might be a really good fit for EPICS?
So the question is design that involves real design, real impact, and real people, and its significance?
Yes.
Well, so I guess one kind of answer I would imagine would be, like, if you compared it to design that was happening in a more artificial situation in a classroom, where they weren't getting as authentic feedback as they would get if they were out in the world and doing actual design, where they will be testing and iteratively getting feedback, so that it's that sort of authentic feedback component that's essential to, that's more significant when you're trying to learn these kinds of skills, is one thought.
That's excellent. That's exactly, you hit it on the head. You were able to verbalize everything that we talk about. That's it. What we want to do is make sure that the students are talking to people to be able to really find out what is needed. And if you have a chance to watch the video that's on the first page of our EPICS, k12.org, there is a really nice video about these students at Nazareth Academy who went through. Hang on just one second. Yes, are you up, Julia? Is that you? Yeah, I can. I'm going to put you on speaker.
Okay, great. We can hear all of you. I just don't think we could interact that way.
Okay.
Through the computer.
Can you guys hear her if I hold it up this way? Do you want to?
Yeah, pretty well.
Yeah. Can you guys hear us?
Yeah.
Great. So Julia, do you want to talk a little bit about EPICS and why you're considering EPICS because of the human-centered design piece of it?
Sure. So I think for us, like, we kind of talked about using it as kind of like the curricular implementation and overlaying it with our National Society of Black Engineers program. And I think that for us, we're excited about the concept of having something that is like using real world applications that can be applied to like a real world kind of group almost, right? So like having this type of design as a process that goes along with a program that is a program that students can participate in across, I think creates a lot of authenticity in it. And I think for us especially, because I personally do a lot of like the community outreach and community service work at our school, having this kind of community-based design and incorporating a lot of different stakeholders makes a huge difference in tying in like curriculum and what students, black students are really getting in education.
It's great. Great. That'll be wonderful. We're looking forward to this. So that's exactly what we're into, and what we're trying to do is help you with this process. So what I wanted to talk with you a little bit about is the what we have developed as far as a program and the curriculum, because I think that that will be an important piece. What we're going to do is talk about the curriculum a little bit, and then after that we're going to talk about a document that can help you to work through the process of developing an idea of what this might look like in your school. So we're going to talk through those two pieces to kind of help move that along. If you see on your screen, I'm hoping that you're seeing the project identification phase on your screen and what that is. What we do through the project identification phase is to be able to have the students walk through and be able to determine what is the best use of their time to learn the most out of for their project, and also to be able to meet their needs as far as academics. So that's how this is designed. So in the website, and I hope that this is going to click there, and I will move that over in just a second. So on the K-12 website, and I think you can see that, you might, if you want to join and go to your website, that's true, you can do that also. But if you look across the website, it's the EPICSK12.org. You have home, main, and then your resource library. In the resource library, I'm going to back up just a little bit. You have the first bunch is the phase where that's a section that's free to everybody who just comes onto the website. From there, we move down, and the next phase, the next section, is our high school curriculum. Now, there is a difference between the high school and the middle school curriculum, because first of all, it's aligned with the high school standards, and then the middle school is aligned to the middle school standards. But also, we wanted to take into account the difference in ability level plus maturity and their developmental readiness to take on different projects and how in-depth it could be. So the high school is the first level, and then the second is down here, where the middle school. You've got your 5 parts of the design cycle, and in between each cycle, you have a gate, which allows the student and allows you to be able to check their progress, so that there are some checks and balances built into the curriculum so that the students have guidelines. And as we go through, you know how it is with any student. They get going, and they don't always make sure they have all of the pieces in place so that they can come up with and facilitate a quality project. This has some checks and balances in there so that the students have to come back to you to show how they've identified their project, like in the first phase, how they've identified their project, or how they've identified the need within the community. Now, the community could be within your school. It could be right around your school. It could be even in your classroom. So you might want to think about that as we develop and you develop your projects. But with the middle school, the first identification phase is, if you look at this, It walks through the introduction, what is introduction to service learning, brainstorming projects, so they start to work on thinking about what their project might look like. There's a survey where the kids design the questions for a survey so that they can get information back in to be able to understand what is needed. The next two are just some pieces of project management that will help. Creating a code of conduct is a really important part because it develops their rules, and then they have their teaming skills and how the different parts of their teams. So I'm going to stop right now and ask if you have any questions, because I'm kind of moving ahead, but I don't want to leave anybody with questions as we kind of move through this. Is there any questions? Adam, do you have any questions? Or Julia and Friendship Academy? Do you have any questions?
One small question.
Okay, Adam, go ahead.
Thanks. So just one small question I had was, I noticed on the page before the one you're looking at, underneath there was a mention of an extracurricular project curriculum.
Mm-hmm.
Is that different in some way?
It is very similar to the middle school curriculum, although, yes, it's very similar to middle school, and yes. So what it is more compacted so that the students are, there aren't as many assessments that go into it, because I know if you're doing it after school, you are not going to be assessing as rigorously as you would in a classroom. So that's one of the big parts of this. Although the documentation still needs to happen if you're going to be authentic in the engineering process. So, you know, that's kind of, yeah.
Yeah, thanks. I do an after-school club, but I'm also looking at it for in-school, so it was just helpful for me to know the difference and be able to think about that.
Right. Probably if you're doing it in school, especially if you're doing it the first year, I would stay with one curriculum or the other, just because, you know, there's a lot here.
Yeah.
No, it's just, there just is. So I want to talk to you a little bit about what is in each lesson. And you, I don't know if you've already started to go through this, but what we've done for all of you is we have given you full access to the curriculum. And the things that we're going to ask in return for that is, one, that you would sign a memorandum of understanding that we are an EPICS school and we are in a partnership with you. So that is one thing we would ask. The second thing we would ask is, as you develop your projects and as you publicize your project to your community and to your school, that you would brand it as EPICS. That would be helpful, and that would be good for us. And as we go through this, we're going to be assessing the curriculum and so forth, so we will ask for possibly some surveys for your students. But also in return, anytime we have funding that we are able to help you with funding for your projects and so forth, you will be able to apply for that. So we will help you with funding as it becomes available. So that's what we ask. But I want to talk to you, oh crud, I hit the wrong thing. Not a big deal, but I want to stay in one thing or the other. So like the introduction to service learning, what is always there is like an overview of the project, and then also there is a PowerPoint that drives the instruction, which is on a Dropbox. So we click there, and then you can download it so that you can adapt it and use it the way you want to. And then also all of these you have the lesson plan, you have exit slips, you have student sheets that go along with it. And as we develop more resources, we'll put it up on the web. That's one of the reasons we like the web, is because that allows us to always, or allows you to always have access to the most recent and updated versions of the curriculum. So that's the reason we have it that way. So what I wanted to show you is, it goes through the brainstorming, the code of conduct, teaming, And then it goes into an introduction of projects through scenarios. So what we want the kids to have some kind of background knowledge of what this might be like. And the best way we could figure out to do it is to create a scenario. And we have scenario cards that are built into this. These are projects that have been completed throughout the United States. And so the kids have these, and they do a basic prototype, which is a prototype doesn't have to be a working model. It's just a way of getting a conceptual idea. And so the students work through how to create a prototype. So through this activity, they learn what are scenarios, what are personas, how a prototype can be used to get more information from a stakeholder, and then also some basics of how it could be used as a proof of concept. So that's what this does, these first lessons here. And then they start going through looking at engineering in their community, and not engineering such as technology, but engineering such as appropriate technology or essential technology, such as in our society, running water, water purification, sewage, something not just an iPad or an iPhone where they think that as technology, but essential technology that works. I wanted to show you, if you look also on the web page, I was able to, and we have these embedded, some of these videos that are embedded, but these videos are also embedded in the PowerPoint. So that will be able to, so you'll be able to use it. But you can also see that these are on there, and they're through, and we've got them on YouTube, so that is able to help you. Now, I want to also, in some schools and where I taught, YouTube was blocked for quite a while. So if you have a situation like that, please let me know, and I will make sure that we get those to you some way. So if you have that kind of an issue with things being blocked in your school, let me know, and we'll work that out. Okay. So also, we wanted to also, if you're a one-to-one school or an iPad or whatever, we wanted to make sure that the student sheets are Word, so they're Word documents, so the kids can take those and adapt them for their use, so they can use it as their artifacts in a digital format, not necessarily in a notebook. So we were trying to think about what might work for anyone and everyone. So that's kind of what we've been doing with this. Again, as you have any questions, please speak up. I want this to be useful to you, not just me jabbering on. Did you have a question?
Can you hear me?
Yes.
Okay. I think we had talked the last time we met virtually around the Word documents, and that's super helpful. Thank you so much for working to do that. We had an internal question. Sorry guys, I'm not sure how relevant it is really to the middle school approach about just the difference between the extracurricular curriculum that's online and the high school, because if we're using this in the after-school program, we were just wondering your thoughts on which one would be more appropriate to kind of go with.
Okay, I'll say the question again. She was asking what the difference between the extracurricular is and the high school curriculum, and which would be more appropriate to use. Julia, are you doing this at the high school level, or are you doing it at middle school?
The high school level.
Okay. We may need to talk a little bit about that, and you're going to be doing it as an after-school high school program, right? Yeah. Yeah. The thing about the high school curriculum is it's set up so that it can be used as an engineering standalone class. So it is very detailed. So what we might need to do is you and your team and Therese and me, we may need to sit down and talk about this and what pieces absolutely have to go into it and which pieces can be put aside. So that,
absolutely. I think that makes a lot of sense. I mean, it's a conversation for us offline because I started having some of my team members who have our engineering background
okay.
kind of looking at it, so you're starting to kind of think about what is the pushing pull. But I just want to share from your standpoint, like, one, how much, we want to keep the fidelity with the program versus that. We can table that and talk at a later time about that, and maybe just connect you with the people who are kind of working on the curriculum aspect of it for our school. But I just wanted to add that.
Yeah, and we will talk about that. And what, again, what we were looking at for that after school was so that it is bare bones. It is the bare bones of what you need to have to get through a project. That's what that is. But if you're really teaching the entire design cycle, then you would teach it, or as much as possible. But I also want to just kind of put this out there. EPICS is not a lockstep program where you have to do this, you have to do this, you have to do this, you have to do this. If you're finding that something is becoming cumbersome, take it out. It is not that you have to do each piece. Again, though, what we found is, particularly with the first, the initial phase of the project identification, it is a lot of work and it's a lot of not building. And kids get really frustrated with that just because they want to get in there and build. But the problem is if they don't do that initial pieces of the design process of really analyzing their stakeholders, they become, they don't get the information they need to be able to complete a project. So that identification phase is an important part of it. So we'll talk more, and Julie will talk some more about this as we get into it. Okay. Any other questions as we're going through this? I know Tish, you're on. Are you? Can you hear us? I see. Yeah.
I can. I don't know if you can hear me. Can you hear me?
We can hear you. Yes.
I don't know if you can hear me.
We can hear you, Tish.
Okay.
Do you want to turn on your webcam? I just sent you a.
I thought I turned it on, but.
Yeah, I'm not seeing it. But I wanted to welcome you in as we're going through this process. Tish is in our Cincinnati cohort. So I just wanted to bring her in on that. Okay, so again, so I'm going to go back to this. With the project identification phase, before any students, either high school or middle school or elementary, moves into the next phase, they go through a gate. And the gate is right between each phase. And that allows, again, for the checks and balances so that you know that the student is ready to move into it and has all the information they need to be successful. That's the whole point. It's not we want this to be cumbersome, but we want them to be able to deliver a project that meets needs and meets their needs. So a part of that gate process is there is a student guide that I've developed so that it walks through and it gives the kids an understanding of what's to happen in that phase, what the presentation should look like, what pieces they need to have. So like here is their project charter document. So it talks through that they need to have done this, and this was again in lesson 12. So this helps them to be able to bring their mindset of what needs to happen, get their information together. Their survey, so they have developed a survey of people that they wanted to find out more information from. So there's their survey results. They're also looking at the project and community partners. So they're kind of identifying that so they know who could possibly be a part of this. So they're developing these ideas so they don't get into, well, we're going to build a water purification system and they have nobody that can use it. So they're making them think about who we can work with, making sure that they've got that information together, developing that relationship with the community partner and the project partners. Also, they're developing, and I'm not sure at middle school if you'd want to do a PERT chart, and some high schools don't even do a PERT chart. A PERT chart is a way for the student to understand that there are activities that can happen simultaneously, but there is a critical pathway that has to happen to be able to complete the project, the important steps that have to happen. So that's what the PERT chart helps to develop. And again, if you find that to be cumbersome and it's not working for you, throw it out. Also, a Gantt chart. A lot of engineers, the reason we use a Gantt chart is because a Gantt chart is something that they use in engineering. Also, one of the reasons I like a Gantt chart is if you use a timetable or a timeline, sometimes kids have a connotation of a timeline that they did in 3rd grade, that I was born, I went to preschool, I went to 1st grade, I went to 2nd grade, but they don't think about that in kindergarten they lost 5 teeth, or that their brother hit him in the head and had to have stitches. They're not thinking about all of those things that can happen at the same time. And that's what a Gantt chart does. It shows that there is progress, but there are people that are doing different parts of it. You can use a calendar. You can use any way of a time frame. But I really like a Gantt chart just because of that, showing how the horizontal along with the vertical way that a project fits together. So it is one of those things. They are also starting to develop a budget. So they're starting to think about how much something might cost to complete. So that gives them information to go back to project partners and go back to people in their community to see if they can get funding. So they're really thinking about a lot of different pieces, which is real design and real engineering, real process. And then they also do their first prototype. I just put that because that is a prototype, but who knows what your prototypes will look like. So that's their, hi Tish, there she's up there. So that's kind of gate 1. And so when they have all that together, they're ready to go on to the next phase, which is their specification phase. So they're taking all of their ideas or what they're thinking might happen, and they're starting to pull in. The goal is to understand what needs to happen, not necessarily how it's going to happen, but what needs to happen. So if you're on the first, let's go through the, on the first phase of our page of our EPICS K-12, Nazareth Academy students were working with a man who wanted to have a treat server for his service dog so that he could interact with him, so that he could bond with this dog. The problem was that he had limited mobility and he wasn't able to hold the treat the way that other able people would be able to hold it. And also he didn't want it to fall on the floor. And what he was ending up doing was taking it out of the bag with his mouth and giving it to the dog, which he didn't like. So the students kind of understood that, but if you get a chance to look at the video, you'll see that they go through, I think there are 6 different iterations and 6 different prototypes, because they didn't necessarily go back and continue to talk to the stakeholder, but they also had some problems with getting hold of the stakeholder and being able to talk to him all the time. So in the specification phase, that's where they're taking what needs to happen and trying to figure out what are the parts of it that will make it happen. So that's what they're working on. So I'm looking at, again, Gate 2, the guide for Gate 2. And again, this is a way for the students to develop their understanding of what needs to happen in the gate so that they're ready for Gate 3. For Phase 3 is the end of Gate 2. So it's looking at, they're developing personas and scenarios. And again, they may not do this. They may just use their regular project partner to do this. But they are looking at detail, and they're looking at the details of this person and what this person needs to know, or what they need. If you watch the video again with our Nazareth kids, what it ended up is that they didn't ask him, they didn't realized that he did not want it to fall on the floor, that he did not want it to happen that way, and he didn't want it big. Those are two pieces that they missed with their project development through the first 5 pieces of this. So it was one of those things, if they had developed the persona and scenario, they might have hit that piece. They're also looking at prior art, so they're looking at state of the art, whatever is out there as far as their project. So if they're developing a dispenser for the treat, like Nazareth was, the gentleman actually came up with an idea. He liked the idea of a Pez dispenser. So that would be something that the kids would put in as their prior art, as state of the art. So they're looking at Pez dispensers. How do they work? So they're analyzing that. So the kids will do that with their projects, so that they're looking at what's out there. They're also then developing specifications. So they're developing what are the pieces that need to happen, and what are the pieces of each part. So if you're looking at a backpack, there are, innumerable amounts of parts of that backpack. You have zippers, you have straps, you have pockets, you have all these different things that have to function correctly for the project to work, or for the backpack to work. So any of the projects will have those pieces that have to work perfectly to be able to make it work. So that's where the kids will figure out the specifications, and then they will test the different specifications that go along with it. And again, it's one of those things where the kids are actually, digging down into the design process to figure out, okay, what do I have to make right? What do I have to make sure works to be able to make this project go? And then they go back through and they're looking at their PERT chart and their Gantt chart. And so that is how they're doing the second phase. So they're kind of figuring that out and moving it along. So it's kind of building on what they've learned before. So I kind of want to stop again to talk about the gates, so that you have an understanding, or you feel like you have that pretty well together. Any questions about that second phase? I'm going to pull that back up so that you can see the different lessons in there. And the second phase, you can see, is much shorter, because the testing of the prototype, that may be done multiple times, and it may be done, and the same lesson be done over and over again with different specifications. So it depends on your project and what happens, and which of your groups are doing what, and which student is doing what. Does that make sense? Mm-hmm. Okay. So gate 2 goes into that. I want to, like in the specifications and the documentation that goes along with the lesson, see if I can open it. So here's the specification docs. So again, it's just an open. And so then the students are able to put in any information they want to and make this as big or whatever as they want to be able to use it, so that they can use it and have it as their document and documentation for their project. So it's kind of ready to go. So our whole point was that we didn't want you to have to create all these documents that go along with this. We wanted to make this as simple and usable as possible, because your projects may get complex, and so if you have documentation that's easy to use, it'll make it better for you, so and more successful for you. Okay. So if there's no other question, I'm going to go on to the third phase, if that's okay. So what we're doing in the third phase, we've taken and we have kind of an idea about a project that we want to do, or the kids do. They figured out what has to happen to be able to do that. Now they're getting into a conceptual design, which is not necessarily a working prototype yet, but it is a way of developing a prototype that could possibly meet the needs. So that's what they're doing. But they're also working on brainstorming. What we're wanting is that we want the kids not to get into a focus of this is how we're going to solve this problem, but to think of, well, there are multiple ways to solve the problem, and what is the best part from each piece of that might be able to be put together so we have the best project available. So we don't want them to get focused in on one idea. We want them to explore a lot of ideas in this conceptual design phase. And as they do that, they will get down to the end where they are developing through multiple prototypes, figuring out what is the best way of coming up with that, with their idea. So again, if we look at the student gate, oops, I hit the wrong, I moved on. On the conceptual design, again, they're looking at their persona and scenario to make sure that they have a good idea of what they're trying to get done. They may need to adapt that and adjust it as they do that, so it may be a living document that they keep moving on. Their Gantt chart is also a living document that keeps progressing as they get more information. Then they're going to be using brainstorming with Scamper, and in the website, hang on, I gotta go back, sorry. So in the brainstorming, there's an activity in here where they use Scamper and the Scamper card. So if you can see that, Scamper is just an acronym to help the students to think through the design process and not critical thinking, but problem solving. So is there ways of substituting, combining, adapting, altering, any of those that they can use? So eliminating, reversing, rearranging. So that's just an acronym for the kids to use. And there are cards here that you can print out so that the kids, and you can take these and print them out so that the kids can use them. So you print on one side and then print on the other so that they can have it. Or you can also put it in their notebook so they have a copy of this. So they have that. So brainstorming, what are their best ideas? They're explaining their original prototype. And again, this is where the new language arts standards come in, because before the students would be doing engineering and doing projects and so forth, but they didn't necessarily have to write about it, didn't really have to talk about it. They could just be independently just building. Whereas in these 21st century skills are that they are able to speak, they're able to listen, they're able to defend an argument, they are able to explain what they thought. So that's a part of this whole process, and it's built into the curriculum. Then they have the multiple prototypes, so we talk about the multiple prototypes, and there's a chart here where they get feedback from the different prototypes from their stakeholder, so that they know which piece they like the best, which pieces they don't like, and so it gives them, again, another document that will help them to sort through these ideas. When you think about kids, they don't have life experiences yet, or a lot of life experiences. So what we're doing is building their skills so that they're able to think critically and problem solve. So we're helping them through that. Also, there's the testing protocol, which will help them to systematically test and figure out what are the testings that need to happen, what is their criteria for the testing. And again, this is an Excel document so that they can use it and make it their own. Also, they're updating their budget, because as they determine which pieces are important from each part of their multiple prototypes, they'll be able to determine what kind of materials they need from this. So they're updating that. And again, they're updating their PERT chart and Gantt chart, again, so that they are understanding how their project moves. So is there any questions about the third gate or the third phase? Probably not. Okay, I'm going to keep moving. So the fourth phase is where they're taking all of their multiple prototypes, coming up with, okay, we want option A from this one, we want option B from this, we want option C from this, and they're pulling it into a detailed design where this is becoming their prototype for their delivery. So that's what they're working on. So again, they're continually going back to their stakeholders, making sure that they have the right ideas, making sure that it fits what they need. And again, for that gate, it has them, one of the important, again, they're updating their persona and scenarios, but one of the important documents of this phase is their DFMEA, which is their failure rating. So it's a detailed design of the failure rating of what could go wrong. So they really do look at, okay, I've got this, I'm going to use an example of my LSME team, which is Learning Math and Science through Engineering, which has produced students in it. And they did a rate, or it's an estimation card using a mousetrap. So their failure mode was working with that arm. There's an arm on it, and the mousetrap and the spring on the mousetrap, and what is the failure rate of that, of somebody getting hurt. So they had to determine, could that be overcome in some way? And our LSME team this semester is going to be dealing with that as a part of that continual process, as in determining what could potentially fail and what could potentially be a problem and hurt people. So that's the failure rating. There's also the usability and reliability test, again, a document that helps them to understand, it's a field testing. So it's not merely that they're testing in their environment, but they're taking it back to their stakeholders and testing it in the field to see what the problems are. Another part of this is a user manual. I know that may seem really counterintuitive, but when you deliver a project, the student needs to think through, how is this project going to continue to be effective even when they're not around to fix things. So in this user manual, the students are going to think about how to problem solve or how to troubleshoot. If there's a problem with this, what could they do? What could the stakeholder do to fix the problem? So that's what they're doing. Also, they're creating a materials list. Now, a materials list, they may want to do that earlier in the process. So the materials list may go back into the specification phase. So again, all of these pieces, if you wanted a group of students to be working on a user manual way up in the second phase, or actually the third phase would be appropriate, that's doable too. But these documents are there for the students to use them. And demonstration of the prototype, so they are they're observing how the stakeholder uses the prototype. So this is a document for them to use and to work with them on that. And finally, the safety analysis, figuring out, okay, what are some safety, if there are safety issues, how can they be eliminated? Again, it goes back to that DFMEA, the failure mode. And again, their HURT chart and the Gantt chart. Okay. Any questions about the fourth phase? No? Okay. Again, I'm just trying to move through this so that you have an idea of what is in the curriculum. And the final phase is the delivery. So the phase is that they are going to deliver their phase, deliver it through, and they're going to pull together all of their documentation to be able to deliver it. And then also, this would be a good way for, if you wanted to grade them, this is a good grade. because they have all of their documentation together, they've got their observations, they've got their interviews, they've got their surveys, they've got all of that together, plus a working prototype, and they're ready to pull it. This could be, you could bring in your project partners, you could bring in community partners, you could bring in community leaders so that they're seeing what you're doing in the EPICS classroom to help your community. So again, they're walking through just getting all of this. This is the basic information they have to, which would be helpful to have. Their project charter, their specifications, their Gantt chart, any decision matrices they use, the DFMEA, testing data, safety analysis, user manual, and their budget, updated budget. So that's basically the curriculum and basically how this walks through the engineering design cycle for middle school. So, and I think Julia will talk a little bit more about how that can work for you. Any questions about that curriculum piece? Julia, did you have something you want to add?
Yeah, I think that's good. It's really helpful. Hear me?
Sort of. Go ahead again.
Okay. We keep going back and forth because we can hear you better in the computer, but you can't hear us in the computer.
That's good.
Our technology situation. I don't have anything to add. I think this is like really helpful for us, especially to go through and have a lot of like engineering eyes on it. That stuff is making us excited. I think the other aspect for us is just going to be the what to prioritize with limited amount of time in terms of the vehicle to make sure that we're kind of moving towards a project.
Right. The thing to remember about this, and I don't know if you heard all of that, they were just talking about how they were thinking through how they were going to use this. And that's what they're doing at Friendship Academy as we talk. And I think Tish is doing the same thing where she is in Cincinnati. But the thing to remember is that this is not lockstep. And however, everybody is different. Every community is different. Every project is going to be different. The whole point that we wanted to give is to give a comprehensive view of this so that if your school needed the DFMEA, you had it. If your school wanted to go as deep and as in-depth as possible, you got it. And we wanted to make sure you had the resources to be able to use this. And we also wanted to be as true and as with fidelity to the Purdue design model and the EPICS design model as possible. So that's what we were kind of working with to make sure that that happened. So the other thing that I kind of wanted to talk with you a little bit about was what this might look like in your own school. So I'm going to pull up a document real quick. I should have put that in my PowerPoint, which would have been a smart idea, but I didn't quite get that done today. So all of you have gotten this project planning document. This is very similar. What I wanted to do was kind of help you to think through what might happen in your community and how you might be able to use this. So the purpose statement, and I don't know if you have this document. Does everybody have the document? Good, good. I always use my own experiences where I taught. I was a teacher in a high poverty area in, it's a suburban area of Indianapolis, and you wouldn't think that it would be high poverty, but we're at 78% poverty rate. And in our community, if I were going to look at this as an EPICS school and EPICS community, I would be looking at, first of all, we have a Head Start preschool along with a senior center of the Goodwin Center, and it's within a mile of the high school. There is also a part where there is a community garden that is by one of the churches that they have a food bank, and then the community garden gives fresh vegetables to people in the community that need, those resources. And also, we have an elementary school where there are no sidewalks. They walk to school, and a lot of times they're walking to school without, there's no sidewalks, plus it's dark. So, that might be one of those things that I would be looking at with that. So, again, the whole point is just to think about what are some potential ideas in your community. So I wanted to take a moment and just kind of, as you're thinking about it, if you would wanted to talk to the group for a minute about what you might be thinking about in your school, in your community, or right around your school, that might be something that would be a potential project. So I always pick on Adam first, so I'm not going to pick on you right now. So, Julia, I'm going to bug you. Hey, Julia, have you been thinking about that with your school?
Yeah, so we've been kind of like debating and going back and forth right now. So we talked about a couple different things. I think that the trick for us is that, this is a side note, but actually in the last month, our school has received twice the number of students. Oh. And so the space and time for where we were planning to implement certain things has changed. I think we have a lot of different projects we can take it in different directions, but really, like, our robotics teacher is here, and we've been kind of talking about, like, how to implement ideas and parts of the design process and overlay it with kind of the robotics principles and what he's doing in the classroom.
Okay.
I think we also have opportunities we're in a new school, and I think, like, potentially projects around working on something that has to do with a greenhouse or, our student community. Like, I think a lot of it must be on the people.
Yeah, one thing I remember this year when we had this question that we posted to students, one thing that came really big was mentoring. So I've been trying to find a need for a project that they could physically prototype. I know that's just where I'm trying to think of. I know also giving them a real worldwide issue is something that we've done before with SLL, which is the first Lego League. So that was something that I was thinking of as far as concept. But as far, I was trying to think of, given that question, a lot of things that they come up with are programs, and those kind of outlets that didn't come up with. It's just hard to think of a solid project to take a prototype. But again, we've used with First Lego League, I know that they've used worldwide issues for them. For instance, I know with Katrina, that was one year that they did on how would you help out with that happening again.
Okay, so you were talking about, and I'm just going to share because I was hearing what you were talking about was your Lego League and some of the projects that you've used with Lego League and the competitions and using that with EPICS. Is that kind of what you were thinking?
Well, yes, because they've used worldwide issues and sort of, when it's faced with catastrophe, what are some ways that they could solve those issues? I think that would be a good outlet or a good way to get a jump start on how they could come in with a prototype and the kind of problem to solve with a prototype. When doing it in a context around here, we see students form a program once they think about their community or their neighborhood.
Okay. Well, and again, if you're thinking about an EPICS project, with an EPICS project, this is a project that the kids would leave with someone and that would make their life better. So as you're developing and you're thinking about your EPICS project, if they're doing a robotics or a program, there needs to be people in their community that will be able to use it, and it will be able to continue to be used long after those kids have left that school. So it's something to think about. Do you see?
Yeah, definitely.
Yeah.
I think we're definitely in the brainstorming stage around
Great.
things, and I think after like going through stuff in depth with you all, I think we need to tease out a little bit more exactly what role we want the program to play in this particular programming that we already kind of have in place.
That's
And I
great.
think that will also define how we present the problems to the students. That makes sense.
Yeah, yeah, and it's just yeah, you've got a lot of great ideas, and we're just thinking things through, but that's what makes EPICS different than a lot of other programs, is because it does impact someone, and it does have a lasting impact on someone. It just like this guy and it may seem like a silly project for a man to have a feeder for his dog, a dispenser for his pepperonis, but for him it is an essential part of his life, and it makes his life better. And the other piece is that this is not only going to make his life better, there are so many other people that have service dogs that are going to make their life better because of this one person. So it kind of expands out from there. So, yes, using all of that knowledge base that happens in robotics is fabulous. And it's a great way for kids to understand and learn how robots work, and the electrical circuitry that goes into that, and then to see how that could be utilized and reconfigured or in some way made into something that could serve someone else. So it's a great project and a great idea. It's a great way of thinking. So yeah. Tish, go ahead. Did you have some more to say, Julia, with your team?
Oh, say that one more time, Jean.
I just wondered if you had another comment or something else that you were adding into this.
Oh, I think what I was just going to say is I think ultimately what the ideal situation would be, right, is that they're taking various engineering courses, they're taking robotics in class, they're gaining a lot of content knowledge around it, and then where we really kind of wanted to bring in perhaps like our NESB mentors and our after-school program is having mentors who are in the community and various engineering responsibilities across the city really help students identify a need that they may see at their job in the community and help students kind of come up with that type of problem, using that as a facilitation for what the project will then end up evolving. And so like using that as a vehicle in our classes as the content knowledge, I think is where we were originally kind of thinking.
That makes sense. It makes sense. It makes perfect sense what you're thinking. It does.
Yeah. I think right now the tension that we're kind of feeling as a team is just making sure that if we want to do that, like how often would we need to visit this, and how, like what is within the realm of the feasible given certain constraints that we have now that we didn't necessarily have when we were thinking this plan through a month ago.
But also remember, it can go very slowly. It doesn't mean that you have to even have a deliverable the first year. It doesn't mean that at all. And like the project with my team, my LSME team, I know they're college students, but they're still going through the EPICS design model for the first time. So there's a lot of similarities in that. But even like one team that has been, not the same kids, but the project, it's the second year on this, and they delivered the project, and it's a robotics project, but they're going to go back and they're going to test it and see how it affected and how it impacted the students it was made for. So they're going back through and maybe redesigning it, figuring out exactly what the testing proved that was done before. So there's a lot of pieces with this. So it doesn't mean that anything has to be delivered first year. There's a lot of engineering is like that a lot of times. There's a lot of projects that take multiple years to complete. So.
Yeah, I think that will ease a lot of concerns that my team is having around that, because I think like that, as I said, is like our vision and our model. We just know the reality, and we think it's just going to move a little bit more slowly than if we were taking a project start to finish in a year would. And so if that's something that seems precious to you, I think that that's really like the way that we would want to kind of implement it.
It makes sense. It totally makes sense. It's not a problem. That sounds great. Very good. So, Adam, did you have any ideas about possible projects that you might be implementing or thinking about?
Well, so there's like a couple different areas. So one gentleman I think mentioned the first Lego League, and so that's not necessarily just robotics in the sense that at the middle school level, for us, we have 3 teams, and it's about 3 months or so in terms of the duration. But part of the competition is building a Lego robot. The other half of the competition is a design project, which very much in terms of the goal of the project and finding a real-world partner and producing some sort of actual deliverable that would get used is very similar to the kinds of things that it sounds like an EPICS project is intended to produce.
Great.
With we've been doing that for a couple of years, and I still trying to figure out what the right kinds of supports and resources to use to help scaffold that process for the kids is. So that's definitely like one of the things I would be looking at, and maybe it would be the extracurricular project one. But the theme for this year, there's always design related to a theme. So at this point, all I know is that the theme is sort of waste and recycling and that sort of thing. So that's one possibility. We also have a community service project or program already in place in the middle school, but we're with ways as to how to tweak it. So like up until this point, the model has typically been that there are groups that a couple of days during the year go out to different sites and engage in some sort of service learning activity, but it's not design or engineering oriented in any way. So this year, the 8th grade is sort of trying to do something a little bit different. At this point, they've decided that they're interested in partnering with Wounded Warriors or some other veterans organization, and I think they're still sort of trying to figure out what the details of that project work might look like. So that's another kind of thing that I'm trying to investigate, what these resources are and how they might be used. So, yeah.
We have a community partner in Virginia that has worked with the Wounded Warriors, and they worked on creating picnic tables for the Wounded Warriors in their retreat, where they go after they get out of Walter Reed to reunite with their family. And what they were designing is their question was, why is it that a person in a wheelchair always has to sit at the end of the table? Why can't they sit so that their family's around them? So they designed a table so that there was a cutout so that a person in a wheelchair would be able to sit with his family on either side of him. So,
yeah. So can I ask one quick question about that? Because this is like always sort of in the back of my mind, and that's a great example to ask it about. So oftentimes it feels to me like, right, once you've gotten to the point that you've asked that question, you're like well on the way to being able to produce a successful design. And so like the mystery sauce or whatever is trying to figure out how you even get to that question in the first place. So I guess I would be curious specifically with that group if you had any further information about like where did that idea come from, or in general like how an EPICS project goes about trying to make that first stage happen.
well, what they do is they start looking around in their community. Now, this is a program that has been in existence for, I think this is at Foxcroft in Virginia, and they've been in existence for about 6 years, I believe. So their projects are getting more advanced as their projects get started. But what they did is their students went out and they observed the stakeholders or the potential stakeholders, and they started looking at how do they react in their environment, how do they, what problems do they see that might be able to be fixed. So they start looking at that, observing and interviewing, and that's a part of the beginning part of that first phase, is actually going out and interviewing people and observing. So they watch and see what are some issues that are happening, and then from there, then they go back and they discuss it and think about it, and just that critical thinking part. We have, and this is a problem in our educational system today, and I think, I'm preaching to the choir here, is that we tell our kids, you do this, you get this done, and you've completed it. Well, in real life, there may not be a one perfect answer to any question, or there may be 5 perfect answers to one question or one problem, but they have to explore it. It's not you telling them or me telling them this is the right way to go. They have to figure out for themselves that this is the best way that they're going to go in this situation at this time. So it's really giving them freedom and creative freedom that a lot of times we don't do in education. So they
Great.
do.
Thank you. Yeah, that helps.
Yeah, so they're observing, they're thinking, they're interviewing, they're developing understandings by watching. And again, I've watched that video from those kids at Nazareth, I don't know, 5 or 6 times, and each time I get something else out of their thinking process, which I think is wonderful. I mean, I really enjoy it as an educator watching them. But, it comes back to, wow, we didn't know he really wanted that. And even though from the beginning he said this is what he wanted or what he needed. So anyway, I'm going to, hang on just one second, I'm going to shut this off. Sorry, it was my phone. So anyway, so that just helps the kids to develop their own understandings. So we can talk through that also. And also I want to tell all of you that we are here for you. Charisse, I don't know if you want to introduce yourself a little bit. Charisse is an engineer, and she is a part of our EPICS team. So Charisse, I'm going to give that over to you for a minute, and if you would tell who you are and your background a little bit, that would really help everybody understand who you are.
Oh, okay. My name is Charisse Williams, as you can see. I worked as an engineer for a couple of years and then went into education. I was in the classroom for 11 years. I taught algebra, chemistry, physics, biology. And then after teaching, I went into administration for an all-male charter school, which was a STEM school. And that's about it. Just joined the team this past Monday, so I'm learning things kind of rapidly. It's a lot to take in, but it's good stuff. So I'm just excited about working with the teachers and the schools and trying to, push EPICS forward.
Okay. Thank you, Charisse. So we're looking forward to having Charisse and having her expertise in working with all the schools throughout, every place. We will definitely, Adam, be up to Chicago to visit you and to talk through, and we can also talk through any of this on the phone. And Julie, I want to talk to you about getting out to DC and talking to you in about a month, where my husband and I are planning a trip out there, a vacation. So I'm going to take a day and see if we can't work out something where I come and see what you're doing and maybe give you some, or talk through some things with you. Tish, are you there? Tish? Hey, Tish. Hey. Hey, do you want to talk a little bit of what you're working on your projects, or you're thinking?
Well, yeah, we actually, I had one of my partners was here earlier that's doing the science club with me, and right now we're thinking this is a little over our heads, actually. Like, just time-wise and what our kids have never had a science club, and so we're thinking right now that it's a little more than we want to get into. Like, we want to just get them hands-on and doing some. So I mean, when I first thought about it, our thought was to help. We have several very special needs classrooms in our building.
Mm-hmm.
Our school is like one of the hubs of all that in our district. So we were thinking of maybe doing a project for one of those classrooms.
Mm-hmm.
But right now we're feeling like it's a little bit over what we have the time to get wrapped around.
I also want to tell everybody that Tish is an elementary teacher, so this is a little different than a middle school or a high school experience. So I wanted to kind of throw that out so that you know that she's not just bailing. So,
We're very interested, and we've never had a club, so just trying to get our feet wet and get started. It's a little, yeah.
Well, the other neat thing is that Tish is a feeder school into one of our EPICS community.
Oh, cool.
So that's neat. So that's good. So if you, go ahead. So anyway, just wanted.
I was just saying, I keep trying to get them involved, but they don't seem to. I don't know. They don't have the time either, I guess.
Yeah, and that's a piece of this. It really is. It is. EPICS is a program that is for those outliers, those teachers that have been. They're the teachers that never teach the same thing the same way every year. They are always looking for something different. They are always looking for ways of making or helping students to become the leaders of their own education. That's what EPICS teachers do. And so, it's always different depending on your environment, what your environment is like. So, I get it. I do. I was in the classroom for 34 years, so I get it. I really do. So this project and this the form over here, it helps you to look through next generation science standards, what standards might go along with your project and content, also the engineering that would go along with it, thinking about community partners, looking at your community profile. What this does is just kind of help you as the teacher to think about what the kids might come up with, because we really want the kids to develop their projects. We want them to think about what could happen and what the possibilities are in their projects. But it's also important to get an understanding of what might happen so that you're not blindsided because they come up with something that's way off of what you thought might happen. It also helps to start thinking about who might be community partners, also who might be community experts. So if you're doing some kind of an electronic, it would be helpful probably to find, okay, Jimmy's dad is an electrician. Sam's dad is an electrical engineer, or mom is an electrical engineer. Or, if you need PVC pipe, you know that George's dad is a plumber. All of these pieces kind of help to make it so that you know what your resources are. So that's what this whole programming or this program planning is to help develop. So, and then also, this also helps to get your information together for your the MOU. So that's what we're trying to do, is get you to plan, but also think about for your MOU, for your memorandum of understanding, the information that we would need for that. So I hope that this helped you to understand. I'm gonna open up for any questions that you may have. And Monique, I just wondered if you had any comments or questions as we were moving through this. Maybe she went and got dinner. Are there any other questions or comments about this? Well, if there isn't, just know that we are here. Remember that our contact information, I'm going to put that up. so that you have, and I'll put Sharice's information on there too. I didn't get that in, and I will do that. But if you email me, I will definitely put Sharice in there, and we will, everything that you send me, I'll send to Sharice, and we know everything that's going on. We're also working on our webpage, but the one that has the content on it is the www.epicsk12.org. There will be people that will be contacting you. We have a student helper that's going to help us with the MOUs and so forth. So to get all of that, the basic information in so that we have that. We're trying to get all of our basic information in by the end of September so that we know who we're working with. So that will be a part of, that'll be kind of a cutoff date. And then at that point, we'll be revising the website at that point to give access to people who are in our EPICS program. So that's what we're thinking. Do you have any questions? Anybody have any more questions? Or any way we can guide you?
No.
No? Okay. All right. Thank you for taking your time to be here. Remember, we're here, and we can do anytime any of the virtual sessions. If you would like us to, as your kids are developing their projects and you want somebody to be watching, or if you want them to pitch it to somebody so that they're explaining their projects, we'd be happy to listen and hear what they have to say and give them feedback on their projects. We'd be happy to do that. Okay. Any other questions or comments? All right. Well, I want to thank you for being here, and we look forward to working with you. So,
thank you.
All right. Take care.
Have a good night.
All right. You too. Bye-bye.
Bye.
And
Hey, Jean.
hey, what?
Jean.
Yeah, Tish, go ahead.
Are you still there?
I am.
Hey, I have a question. If everybody, are you done? I'm sorry, did you want to say, Trace, did you need to say something?
No, we're good.
No. So, Jean, okay, hey, I ran into a guy this summer. I went to Uganda.
Oh, yeah.
And one of the people that I met that does quite a bit of work in Uganda, this was an interesting thing that I'd never thought about, and it made me think about, like, EPICS, that maybe there's an EPICS group somewhere at the college level that might want to tackle it. But this particular gentleman is a retired, I think he taught engineering at one of the universities, and I did have his card, and I might have lost it, so I'll track him down again. But I know I know how to get a hold of him. But
okay,
so he's working. He's basically an engineer, and here's the challenge. The challenge was that obviously in Uganda, one of their biggest challenges is running water. But even when they have running water, then it's sanitation. Now, what's happened is a lot of people are going into a lot of these countries like that and giving them running water. They're giving them a well system. But like in Uganda, here's the problem. Most of the well systems that we want to go in and build in most countries are very developed, state of the art. But like you take a country like Uganda, I mean, it's like going back 50 years.
Yeah.
And so it was interesting because this guy explained that they went in and put some well systems in some of these mission areas that we work with, and now if the well breaks, well, they can't fix it.
Oh.
Plus, the well just trickles the way that it comes out or whatever. I mean, I'm not an engineer. I don't know much about that. But he said the real challenge is to bring well systems to countries like that are not state of the art, but are like 20 or 30 years technology reverse. Because then with a hammer and a wrench or whatever, they can fix them. But when we make them state of the art, they can't. So anyway, it's just an interesting concept that oftentimes we're modeling and designing and building improved items, but here, like something that's very basic, getting water out of the ground,
mm-hmm.
It's not really that we need a state of the art. We need something that works. And the problem then is, because it's so slow, Mama sends 5 of her kids to get water from or one of them, to get water from the spigot that's, 2 miles away. And it's so slow, 8 hours later when he gets back, she beats him because he didn't have water there, 5 hours ago. So it's just an interesting concept that we develop and design state of the art. But like in this country, we actually need to be designing things that are almost reverse engineered so they can fix them with a hammer, and it's easy to train them to fix them. And so it's just funny.
Yeah, Bernard, I don't know if you've heard of Bernard Amadei, and he's the Engineers Without Borders.
Bernard
Amadei, and he talked about appropriate technology, and we use that in one of our lessons, is appropriate technology, because a snow shovel would not be appropriate technology for a tropical climate. So appropriate technology. But we have one of our teams, and I'll have to think about this. One of our teams was working with one of our, I think an African country, and I can't remember where, but they had, their water system was downhill, but it was on the lower level, and their village was up. So they had to figure out a way of pumping the waters uphill. So and without electricity. So they were developing this process and this project that would do that. So this may be one of those things that we could give this gentleman's contact to this team, this EPICS team that's already working on a project. And
no, that's awesome. I will get his information for you and pass it on.
That'd be great.
That's awesome. No, and that is the thing. Like, we went to one place where they had a pump system, and matter of fact, it runs like a whole orphanage and village